Regression analysis is yet an important topic in statistics or quantitative methods that helps ascertain causality to ascertain to what extent one variable is affected by the other. So we're going to look at firstly the concepts under regression. To start with, a relationship can either denote a positive or a negative direction. So for the direction, we use what we call a correlation coefficient. So we can either have a negative direction, like this one, which is downsloping, or a positive direction, like this one, which is upsloping. So this is called coefficient of what? Correlation. Coefficient of correlation. The direction in other times may just be straight like this. This means there's no relationship at all. So we also could ascertain the relationship in terms of intensity using what we call the coefficient of determination. This is a positive relationship. This is a negative relationship, except that one could be stronger and one could be weaker. We're using the dots that are being closed. So if you have a strong relationship, it means you have the dots that are close to each other like this. So this is a positive, strong relationship. The strength of the relationship or its weakness is determined by what we call the coefficient of determination. The direction is determined by the coefficient of correlation, which is R. The strength is denoted by the coefficient of determination, which is R squared. So coefficient of what? Determination. R squared. So this can also have dots which are further away from each other. This means there's a weak relationship. All right? So it means our coefficient of determination is what? Weak. A positive but weak relationship. Even in the negativity, yep, relationships that are negative but strongly negative. So this is negative relationship, but what? Strong. How do we know if the relationship is strong? If your R squared is more than 50%, a strong relationship. If your R squared is less than 50%, or specifically less than 30%, it is what? A weak relationship. If it's between 50 and 30, it could be a moderate relationship. So it is important to categorize the relationship in terms of intensity. Okay. So regression analysis is also important as you're doing your research works because it will help you really understand, if you're a marketer, the extent to which your sales are determined by your advertising. So we use what we call the prediction equation, y is equal to a plus bx. Now I'm going to break down these formulas into 10 simple formulas that I need you to memorize. So number one, our regression equation is simply given by a plus bx. So this means our a is the y-intercept. It's cutting the y-axis here. I love graphs because I also teach economics. I mean, like, I'm an economist. This is just a by the way. So our a is called the y-intercept. An intercept is simply a cutting point. Our b is the slope or the gradient. So we have sub-formulas that we need to know. There's what we call the sum of square xx, the sum of square yy, sum of square xy. So here, sum of square xx is simple summation of x squared minus sum of x to the power 2 over n. Just x is throughout. Sum of yy, sum of y squared minus sum of y to the power 2 over n. Sum of xy, xy here, and summation of x, summation of y over what? N. So I need you to take note of these because they'll help us understand these other small formulas. So I'm still on this regression equation. This is also called a predictor equation. It is used to estimate or predict what the output would be when you input something. So this is our input, this is our output. So to find the b from the sum of squares is simply sum of x, sum of xy over sum of xx. That is how we find the slope. R, what did I say R stands for? Coefficient of what? Correlation. It is sum of xy over square root of sum of xx times sum of yy. R squared, what did I say? It's a coefficient of determination. Just multiply R times R. What is remaining? Our A. Our A is simply summation of y over n minus a slope, summation of x over n. So please remember these formulas. For ladies especially, you've got very good memory. So you need to channel that memory you use to remember what we do to you people. That anger of how you remember the t-shirt we wore, now channel that energy in remembering these formulas. All right. So if we have x and y, this is similar to the discrete random variables we once did, and you're given values of x, maybe 1, 1, 2, 2, maybe 4. So learn to complete this table. How to complete this table? You need to find xy, you need to find x squared, you need to find y squared. Can somebody help me fill in this? So xy, what do we have? 1 times 1, 1. Here we have what? 2. Here we have what? 6.
6.
8. 20. X squared, we're squaring this. 1, 4, 9, 16, 25. Y squared, we're squaring this column. 1, 1, 4, 4, and 16. So the sum total here is summation of x, summation of y, summation of xy, summation of x squared, summation of y squared. Let's total up. Then our n is the number of pairs we have. 1, 2, 3, 4, 5. So help me find the totals there. Here what do we have? 15, 10, 37, 55, and 26. Okay, so let's start with sum of squares xx. Remember, the formula is what? Pregnant with x's alone. What is x squared? 55 minus what? Small x is what? 15 to the power 2. Our n is what? 5. So you're going to have 55 minus 45. So our sum of square xx in this case will therefore be 10. Okay, now help me find sum of square yy. Calculate there. I'll just give you the formula. And find the sum of square xy. I'll give you just a minute for each. So 2 minutes. So calculate that.
Thank you. And for our sake.
So to find our sum of squares, these are very important because they'll predict our mean, they'll predict our gradient, they'll predict our r and r squared. So I've already shown you how the sum of xx is done. You simply need to follow this properly. X squared was 55 minus x to the power 2 over n. So 15 squared over n, which is 5. So this is how we got the 10. Then y, this is some variation in y. So y squared, we have 26 minus the small y. Please don't confuse these two. This is y squared 26. Then the y all squared, this is 10 to the power 2. So over 5. So 10 squared over 5. So here we have 26 minus 20 to get the 6. So this is sum of square y. Then xy. So we have 37 minus summation of x times summation of y. So 15 times 10 divided by 5. So this will be 30, because 5 into 10 is 2. 2 times 15 is 30. So the 7 minus 30, we get a 7. So this gives us the sum of square x 10, y 6, and xy is 7. Then these ones, we get them from the table. The sum total of y was 15, x was 10, and n is 5. So how do you find the slope? The slope, make sure xy is on top and xx is down. The form of the slope is very close to this formula for the coefficient of correlation. So these sum of square xx and yy are very important because they help us understand this. So 7 over 10, which is 0.7. This is our slope. So already in this equation, a plus bx, where there is b, we put 0.7. Then now we need to find our a. So we have found our b. So to find our a, summation of y over n minus b, which we just calculated here, summation of x over n. So here, summation of y is 10 over 5, which is 10 over 5 minus a b, which is 0.7, 15 over 5. So this is 2 minus 0.7 times 3. So this by that is 2.1. 2 minus 2.1, we get negative 0.1. So we multiply this 0.1 negative plus 0.7. We just substitute these two. 0.1 negative. The b here is 0.7. So when you fuse that in, this is our predictor. The next question that will come is predict y if x is 10, or they'll give you any figure. Undoubtedly, they'll tell you what y is. For instance, this is sales and x could be maybe advertising. Then they'll say, if advertising is 10, what is your sales? So you put where there's x, you put 10. Then they'll ask you what is the coefficient of correlation. The formula is xy over square root xx times yy. All right, so sometimes the formulas, they'll extract these ones. Here they'll put summation of the same breakdowns that we had. It looks like a long formula, but I'd rather you understand this simpler formula that I've given you. So where there's xy, this is a 7. Xx is a 10. Then just introduce the yy, which is the 6 there. So we're going to have 7 times 10 times 6. When you compute that, we get 0.903. Here, we're only interested in the sign. If we're the negative, we say it's negatively or inversely related. If we have a positive, we say it's positively or directly related. Then when you square this answer, it's called coefficient of determination. It explains the extent to which y is affected by x. So here, when we square it, we get 0.81677. In percentage, you multiply by 100, which is 81.67% of y is because of x. So this is how we determine causality. So this is a strong relationship. If it is sales against advertising, we say our sales are 81% as a result of us advertising. And so if you want to convince management to increase your advertisement, you could probably use the R squared because it predetermines the extent to which our advertising budget is effective. Is that clear now?
Absolutely.
All right.